In this tutorial, we are going to be looking at the HH equation. The HH equation is a helpful tool for understanding how pH of a buffer solution is related to the concentration of acid and its conjugate base. A buffer solution, in simple words, is a solution that resists a change in pH. You can choose to put it differently by saying a buffer solution is a mixture of a weak acid and its conjugate base, and this helps us to keep the pH of the solution relatively stable even when new added small amount of acid or base. So, and the HH, this simply means, or this simply stands for Henderson, Hassel, Balch. And this guy here, he have his equation to be given pH, which is equal to pKa plus log of the concentration of A minus divided by the concentration of HA. Don't worry, we're also going to look at that. In this case, notice that here we're given the pH. What does this stand for, or what does it mean? The pH, this is simply the measurement of how acidic or basic a solution is. Notice that when we have a lower pH, what's really going to happen? The result is going to be more acidic. And when you have higher pH, the result is going to be more basic. Feel free to write this one down. It's going to be important for you. Next, we are going to be looking at is the pKa. This is simply a measure of how strong the weak acid is. If its negative logarithm of the acid dissociation constant, which is Ka, and notice that when we have lower pKa, let's say we have lower pKa, this simply means we're going to have a strong acid. The next thing we're going to be looking at is the A minus. What do you think is this A minus? This represents the concentration of the conjugate base in a solution. Notice that the conjugate base is what you get when the weak acid loses a hydrogen ions. The only thing we're going to be left at this point is the HA, and this is the concentration of weak acid in the solution. And finally, which is this at the middle, the logarithm log. We can call this logarithm function. It helps us to understand the ratio of concentration in a very simple way. So, now let's look at how everything works, starting by looking at the role of pKa. Notice that the pKa, this simply tells us how easily the acid gives up hydrogen ions, meaning that when you add this to the logarithm of the ratio of the concentration, it tells you the pH of the solution. What about the ratio? In this case, this is what we have as the ratio, which is A minus divided by HA minus. This ratio shows how much conjugate base you have compared to the weak acid. If the ratio, let's say we have a higher ratio, this means we're going to have more base. And if the pH will be higher, this means we're going to have more basic. What about the ratio? In this case, let's say we have the ratio is lower. Notice that this means less conjugate base. And if the pH is lower, this means more acidic. Now let's look at one problem and then call it a day. Let's assume you're given this kind of problem which says you should calculate the pH of a buffer solution that contains 0.20 molar of acetic acid and 0.10 molar of sodium acetate. And we are given the pK of acetic acid to be 4.76. How can we solve this problem? Notice that we are given the weak acid concentration, which is HA. We are given to be 0.20 molar, right? What about the conjugate base concentration? Notice that the HA minus, this simply means conjugate base concentration, and we are given to be 0.10 molar. Now notice that this is acetic acid and this is acetate ions. What about the pK? The pK is at the end of the statement of the problem, which is 4.76. So the first thing we need to do, now that we have identified these values, next thing we need to do is to plug the values into the equation. And if you could remember, we said the HH equation is given to be pH, which is equals to pKa plus log of A minus. And if you could remember also, we said the A minus is conjugate base concentration. The conjugate base concentration in bracket divided by the weak acid concentration. And we said which acid is going to be HA, positive. So inserting our value, notice that this is what we're going to be looking at, which is the pH. We're going to repeat that. What is the value of pKa? This is the value of pKa. We're going to replace that, which is going to be 4.76. What about the log? Let's put back our log, but open the bracket and put our value of A minus. And we said A minus is conjugate base concentration. And this is it for this problem. In this case, we're going to have 0.10 in molar. Molar will cancel out, so we don't need to write that. This will cancel with this. What about the denominator, which is HA, is going to be 0.20. So, at this point, next thing we need to do is to calculate the ratio. This is what we're going to be looking at. So this is going to be 0.10 divided by 0.20. If you divide both sides, we are going to end with 0.5. Next thing at this point is to take the logarithm of both ratio. Here we're going to have log bracket of 0.5, which is simply going to be it's going to be negative 0.301. So at this point, what we're going to be looking at, what we're going to do next is to add this to the pKa. If this is negative, if we add is going to be positive, if this is negative, positive, negative is going to be negative. Here we're going to have the pH to be 4.76 minus 0.301, which the value of our pH is simply going to be 4.459, and this is it for this problem. Thank you for watching. I hope you find it very helpful, and if you do, don't forget to click on the subscription button below. Thank you and see you next time. In this tutorial,